So today I would like to talk about Scratch. Scratch is a programming language. It's a nice, it's meant to be simple at least, and you can do some really cool things really easily, and that excites me to teach it too. So to get there, you can just search for Scratch, Scratch programming language on the internet, or the actual link is scratch.mit.edu. That's where you need to go right now, please. Scratch.mit.edu, yes. Log into this computer itself. Yeah. You'll just have to restart it. For some reason, they don't give me the passwords. Sorry. So yeah, those of you who walked in, make sure to do attendance. I will stop that eventually. But yeah, scratch.mit.edu. That's the link. You can search for it on Google as well. It's like MIT Scratch from that college. All right. Thank you, MIT people, for it. And I'm going to go to the other page as well. But yeah, I guess let's talk about it first. Well, eventually, once you get to scratch.mit.edu, you'll click Start Creating, and here's kind of what it's going to look like. It's a graphical programming language, and I will explain this in detail in just a second. It's going to take some time. I think I might have to refresh the page. I remember this happening previously. There it goes. So this is Scratch, and it's a wonderful, wonderful programming language. This on the left side is your code. They're little blocks, it's like Lego blocks that you can stack to build code. It's really cool. And yeah, there's a bunch of different ones that you can scroll through. And then in the middle is where your program goes. And so we'll eventually put blocks there that stack together. And then on the right is where your program runs. So like you can create little animations and skits and things. It's all going to be visual. And so the default person that appears in your program always, it's every individual image that you can move around and mess with is called a sprite in Scratch. And this is the mascot of Scratch. It's called the Scratch Cat. So the dude has his own Wikipedia page. You can use any pronoun with Scratch Cat. And yeah, just a cool little guy. And he has lore. You can scroll down, read his Wikipedia page. It's really cool. So that's Scratch and the Scratch Cat. And so that's where we're going to be today. I highly, highly encourage you to be on that page and try to do what I'm going to do. I'll give you some chances in class. I'll stop and like have you try stuff and help the neighbors around you, stuff like that. And make sure to yell at me, ask a ton of questions as well. Okay? So yeah, let's do it. So I guess the first thing I want to talk about is just like programming in general, because I assume a lot of us have not programmed before, right? So let's talk about what does it mean to be a program? What is a program? What is an algorithm? Some new terms, right? So lucky for you, if you have ever like modified a recipe, you have programmed essentially. All a recipe is a sequence of steps to do something, right? And that's another word for algorithm. That's a new key term. So an algorithm is a sequence of steps to solve some problem. It's just a recipe. So if you ever created a recipe, modified a recipe, you've been a programmer. If you've ever followed a recipe, you've been a computer, essentially. Okay? So that's pretty cool. And the program is made up of a bunch of little mini algorithms spliced together. Okay? So I'd like you guys to all think about being a programmer right now. So let's say that I have amnesia or I'm not familiar with U.S. culture. Could somebody please tell me the algorithm for making a peanut butter and jelly sandwich? Someone who doesn't know where I'm going with this. Say I've forgotten. How do you do it? What's the recipe? Program it for me. What are the steps? Very nice. Mm-hmm. I guess some people do that. Mm-hmm. Mm-hmm. Very nice. Beautiful. Thank you for that. Yeah, that's a recipe. Is that what we had in our minds, right? That's a program, essentially. If you were like me, when I was taking CSCI 1, here's probably what I would have said. I think you probably know where I was going with this. So I would have said something like, oh yeah, peanut butter and jelly. You get bread, and you put peanut butter on the bread, and you put jelly on the bread. Ta-da, right? It's probably what a lot of us thought. And so let me pretend to be a computer running that program. Your program was a good one. Let me run that one instead. So like, I'm going somewhere with this. So like, all right, if the recipe is get some bread, put peanut butter on the bread, and put jelly on the bread, and it's done. All right. Well, if I were a computer running your program to make a peanut butter and jelly, then I would get the bag of bread. Here's my best 3D drawing of a bag of bread. The little individual slices, right? And you're like, all right, get the bread. So as a computer, I got the bread. And then like get peanut butter, put the peanut butter on the bread. So, all right, I, the computer, would be, okay, here is the peanut butter jar. I will stack it right on top of the bag of bread. And then, okay, get the jelly too and put jelly on the bread. And so I will get the jelly jar, stack it on top of the bag of bread, and voila, that's what you wanted, right? That's peanut butter and jelly, isn't it? Definitely not. So I guess what I want to tell you right now is computers are super smart. They're good at doing a lot of computation very quickly, but they're also very dumb. You kind of have to talk down to the computer when you're programming it because it can only understand so much and there's ambiguity. So yeah, computers follow your instructions to the letter just in terms of what they know how to do. So what I want you to do in this class is to write the advanced peanut butter and jelly algorithms to understand what the computer understands and to talk to it in that way. All right, so that's called computational thinking. I want to teach you how to think computationally in this class when you're programming. All right, and that involves using tiny little bite-sized steps, breaking down your problems into those that the computer can understand and for which there is no ambiguity, and then also, yeah, just being very specific and knowing to do one thing before another thing. So, like again, a better algorithm for making a peanut butter and jelly would be like, all right, go get a plate out of the cupboard, put it on your counter, go get the bread bag out of the pantry or whatever, take 2 slices of bread out, put them face down on the plate, go get a knife, put it in your right hand, go get the peanut butter, open up the peanut butter jar, put the knife in the peanut butter jar, spread some peanut butter on one of the slices of bread, do the same for the jelly, put some peanut butter, or put some jelly on the other slice of bread, and then stick them together where the peanut butter is touching the jelly, because you could have done it the other way, couldn't you? You have to be very precise with the computer, all right? And then there's your peanut butter and jelly. Okay, so that's the differing levels. Like humans can understand what you mean, and they can infer things. Computers cannot. Okay, that's where we're going. Any questions about that? So it'll be fun. You'll learn. Yeah, so let's talk about how Scratch works. Scratch, like I showed you, it's a wonderful graphical programming language, and it's like you're stacking Lego bricks on top of each other, and each of those bricks do one thing. Okay, so here's kind of how Scratch will work. You'll make a program by dragging out blocks, and each of those blocks, they fit together just perfectly. It's beautiful, and they each do one thing. All right, it's like this is a block that does operation 1, and then you stack it on top of another block that fits perfectly called operation 2. And then you stack it on top of some other block that does operation 3. And the idea of a program is you stacked all these together. When you run your Scratch program, it's going to do all these operations from top to bottom in order. Right? That's what it's going to do. And that's how it will work. And that's what it means to run a program. All right. So another word for run, by the way, is execute. All right. So it's not like your computer is murdering your program, but that's just a synonym. So execute is the same as run. And so all of these blocks are going to be executed in order. Execute in order. Another word for execute is run. Okay, so just in case you haven't heard that. So now I think I'm ready to show you Scratch. So it's scratch.mit.edu if you haven't gotten there yet. Go play along with me if you'd like. And so what I want to do first is make a program that prints to the screen the phrase "Hello World," because if I didn't do that, they would take my computer science card away. That's just the thing you do when you learn a new language. The first program you're supposed to make is one that prints "Hello World" out to the screen, just to like prove that you are in control of the program, and then it's talking back to you. Okay, so yeah, let's do that. Let's make a program that prints "Hello World" to the screen. Let's find the block. Does anybody see the block? Have you scrolled down enough? Does anybody see the block that might say something out to the screen, print something? Yes. The look section, the purple ones, yeah. Aha. Very nice. Yeah, say hello for 2 seconds or just say hello. let's try both. So what you do is you drag it out here. In the middle is where your program is. And I'll zoom in. And that technically works. You can change this, right? Change it to say exactly hello world for 2 seconds. And then to run your program, one way to do it at least, one way to run this block is to click it. Click, and then it will run in the right side. So there it is, the Scratch Cat. It's his program right now. He's saying hello world. All right? Isn't that cool? We did it. Let's see. Are there any questions about that? That's a program technically. What else do I want to do? This other one, say hello just by itself, that one is just like it never goes away until you say something else, essentially. That's what that one means. If you want to like get it to go away, you can click this stop button, and then it will like reset itself. And so if I wanted this one but not this one, I'm like, I'm done with this one now. You can either drag it back and then it'll go away, or you can delete block. Either way. But the idea is you can stack these on top of each other. So like you can do cool motion stuff in the blue section. Like I guess I should talk about sprites in general. So a sprite is just something you can move around in your program. And then here are all the sprite's properties down here. It has a name. By default, the Scratch Cat is named Sprite1. We can give him a name, like a real name. Call him the Scratch Cat. If I can spell Scratch. Scratch Cat. And then notice if I can drag him places, his coordinates are changing. So there's a concept of a coordinate system, and 0, 0 is right in the middle there. See that? Like I go that way, it's negative x, positive y, negative y. See how that's changing? So you can use a program to move him using coordinates. You can show or hide your sprites. You can change their size. It's like a percentage, so like 200%, the giant Scratch Cat. 50% baby Scratch Kitten. There you go. And then like there's also a direction. Like what direction is the Scratch Cat facing right now? And you can change that before your program starts if you want. So you can go any way you want, and I guess by default it was 90, right? 90, so facing straight to the right. That's what they consider 90 to be. I guess it's relative to upwards, going clockwise. All right, so back to 90. Hard code that. There he is. These motion blocks like work in terms of those things. So like move 10 steps, that block means move 10 steps in your current direction. So when I click that, his x will increase by exactly 10. So when he's at 4, he went to 14. See that? That makes sense. And so these are programs that you can combine. Like this one can go underneath that, and like there's a turn amount of degrees block. You can click that to run it, or you can like make it a bigger program. And so what's going to happen if I run this now is he's going to say hello for 2 seconds, then he's going to move 10 steps in his current direction, and then he's going to turn 15 degrees. Does that make sense? That's the program. It'll do all that. So the first thing that happens in the whole world, it takes 2 seconds, right? And then he did the thing. These other two are kind of instantaneous. But you saw it happen, right? Are there any questions about that? That's pretty cool. Pretty fancy, right? So let's just keep the hello world, I guess. Get him back to normal. Because that's a program that I want to give to you. Let's see. That's the first one I'm going to save. So I'm going to save this so you can have it later. But I think you can understand it. All right. If we are good, let's talk about some more things. So clicking blocks is not the usual way to run a program. It's the lazy way. So in Scratch, normally, we would like to use an event. It's called an event to start out our program. It's just something that happens. There's a bunch of different events. And so yeah, clicking on a block is cheating. So what we will do, a standard way of doing it, is to use this green flag to start our program. When we click it, it will run all of whatever our program is. Okay? So that's here in events. And notice you can see how these start computations, these start programs, because there's no hook in for something above it, right? This is the start. There's nothing that could go above an event. Does that make sense? That's going to start the program and everything underneath runs. So now, when this event fires, whenever the green flag gets clicked, it will run whatever's hooked into it. Does that make sense? Questions about that? So now if I click the green flag, you'll say hello world for 2 seconds. Yeah? We good? So that's pretty nice. Let's see. What else? There's other events that you could look into. They have to do with like keyboard and stuff, so you can make a game very easily with that in mind. So yeah, events start computations. And then also, I want to talk about comments because those are super nice too. If you right click on any of your blocks, you can add a comment. And that's just a little sticky note for you, the programmer. It's something that you want to like remind yourself later when you open up your program again, just to remind yourself like, what was going on? What was I thinking? So this program is so easy, it doesn't really matter. But eventually, you're going to want to use comments. So let's just say, all right, this block prints hello world for 2 seconds, even though we know that's very obvious. All right, it's not part of the code. A comment is not part of the code. Let me zoom out. It's just there as a sticky note, as a help for a programmer. All right, useful when you're sharing your code as well. You're working in a big group. So yeah, that's what a comment is. And I think that is what I wanted to say. I guess this is like the best way to do it. Let me save that one instead. Okay. So yeah, I think that's the start. Are we ready for a more complicated program? Any questions? All right. So my silly first example will be, let's make a program that's an animation. Let's have an animation where the Scratch Cat is hungry and he likes bananas for some reason. I don't know if cats are allowed to eat bananas. I'm not sure. Maybe. Let's assume they are in this universe. And the Scratch Cat goes to the fridge, opens it up, gets a banana, and walks away with the banana. All right? So that's what's going to happen. That's the program I would like to write now. And so we are going to create movement. All right? We're going to create movement with the Scratch Cat. And so we're going to be very, very reliant upon these coordinates. All right? So there is a coordinate system for every sprite in your program. And I think they usually just start at 0, 0, but 0, 0 is the middle of the screen. You can go upwards, that's increasing your y, and go left, that's decreasing your x, right? So that is going to be very important. And so let's set the scene at least, and then I'll show you my algorithm. I'll show you my thoughts for how to do it. So I'm going to say file new to just replace everything. It's like, are you sure? I am sure. And so let's do a few things. So I like the Scratch Cat to have a name. I'll give the name Scratch Cat. Just my personal preference. So I need the Scratch Cat for sure in this program. I also want to set the scene. There are things called backdrops. If you click this button, it's not choose a sprite, but here choose a backdrop. That green button in the bottom right. If you click that one, you have a bunch of backdrops. So it's like a little skit that we're making here. And I think there's one that has a fridge. So there's a refrigerator. Click it. So there's my refrigerator backdrop, and now the Scratch Cat is in front of all that. That's pretty cool, right? So there's that. So the Scratch Cat needs to be in the scene, and then there also needs to be bananas that will move along with him. So that needs to be another sprite, okay? Sprites are things that you can manipulate with code. The backdrop's just kind of like the scene. So I'm going to choose a new sprite here as well. So I'll click this choose a sprite button, and there are bananas. So there's the bananas, and I will bring them into the program as well. Okay, so here's the bananas. They will start out in the fridge, right? And then here's the Scratch Cat. Maybe he's going to start out over here so that he walks towards the fridge. Okay, so that's the scene. We got 2 sprites in the scene, and then we chose a backdrop. Excuse me. Questions about that? And so we're going to manipulate both the bananas and the Scratch Cat with our program now. All right. So here is my silly algorithm. Let's think. I thought hard about this, so let's figure this out together. So yeah, there has to be like a concept of the Scratch Cat not being near the bananas right now. So the bananas are in the fridge, Scratch Cat's far away. That's first step. And then what we're going to want to do is have the Scratch Cat walk over to these bananas, right? Walk over to those bananas, and that's going to be with one of these motion things. I have a feeling this glide block is going to be very important. We're going to glide over to the bananas, and it's going to take some time to get there. It's going to take like a second or 2 seconds, however long I say it should glide to this particular spot, whatever. And so as the Scratch Cat's gliding over, the bananas need to stay still. Bananas must stay still, and then they'll walk away with the Scratch Cat. Okay, that's kind of the process. So that's going to be important. So the bananas, let's have them wait 2 seconds because that's how long the Scratch Cat will take to get over to them. All right, and yeah, let's do that part at least. So here's the start. When the green flag gets clicked, I would like to do the following. And right now, by the way, I'm talking about the Scratch Cats program. You can have a different program per sprite, and we're going to need that. We're going to need a program for the bananas as well as for the Scratch Cat. So like when the green flag gets clicked, we need a program for both of them. They'll both run at the same time. This is actually something that we don't even teach until a very advanced computer science class. This is a concept called concurrency. It's amazing that we can do this in Scratch so easily. It's like 2 programs running at once. But that's what we're going to do. There's a program for the Scratch Cat and a program for the bananas. We're going to do different things. Right? So in the Scratch Cats program, when the green flag gets clicked, he needs to like walk over to the bananas to get to them, right? So he's over here, and then he needs to glide over to exactly, let's say here. And notice how these blocks are super helpful. Like I want the scratch cat to eventually be at, let's say here, -167, -85. I don't have to type that anywhere. If I just put him where I want him, do you see how the glide block has changed to his current location? And if I glide him somewhere else, again, it's changed to his current location, so that's very helpful. So like I want him to be here eventually, exactly there. And so I'll just drag out the glide block while he's there. And I want him to take 2 seconds to do that, please. And I'll put him back. All right, so now when I run the program, click, he's over there by the bananas. Does that make sense? That's pretty nice. What do I want to say now? Yeah, so that's how that program works. So walking over towards those bananas, and so the bananas need to wait before they glide off with him. Yeah. There is an issue right now, though, isn't there? If I click the green flag right now, what would happen? What are our thoughts? I think there's an issue. Yeah. Very good. Yeah. Does everybody see how like he'll take 2 seconds to glide to exactly where he is right now? He's not going anywhere right now. So that's kind of sad and useless, right? So let's fix that. I think what we should do then is start out the scratch cat always over here when we click the green flag so that it's looping properly, right? It's going to start over properly. So that's where the scratch cat needs to be at the start of every program. Does that make sense? Because otherwise, he's just like already there. He's not going to do anything. It's going to be a different thing. So we want to start him out over there. And so this go-to block will just warp him there, right? So at the start of the program, if he's not already here, put him there, and then he can glide over. Whee! There he goes. And so now when I click it, he will warp that spot, that coordinate, and then go right to there. Any questions about that? That's very important. All right? That's going to make the program rerunnable. That's pretty cool. All right? So it's going to take, right, 2 seconds. The blocks that don't have seconds attached to them, they're instantaneous. So it's going to take 2 seconds total, right, for both of these blocks to run, and 2 seconds then to get to the bananas. So the bananas, their job is to walk away with the scratch cat, essentially. So let's, I guess let's finish the scratch cat program. Like he's going to walk away with the bananas back to here, let's say. He's going to walk away with the bananas back to there. And so let's glide him back to that spot and take 2 seconds again to do it. You can make him faster or slower. Maybe he's running with the bananas, who knows. But like that's the scratch cat's program. He starts out over there, goes to there, gets the bananas, and walks away with them. And that's his job, okay? The bananas have their own program. It's now our job to make them walk away with the scratch cat, all right? So he's at the fridge after 2 seconds. Yes, that's the secret. And so eventually the bananas, like we want to have them glide away. We want to have them glide away with the scratch cat to right there, maybe, or right here, there, something like that. So eventually we want to do that with the bananas. This is the bananas program. Clicked on the bananas sprite. They have their own separate programs. Like take 2 seconds, please, bananas, to get over to there. But this is too soon, right? So here, let's put it back. Scratch cat is doing that. Here's the bananas program. If I click the green flag right now, both of those programs run at once. So watch what happens. Whee! The bananas are like haunted and they pass each other. So what needs to happen is they need to wait those 2 seconds as the scratch cat is getting over to the fridge. Yeah? That's what needs to happen right now. Because then, only then, will the scratch cat be touching them essentially and like physically there. So let's make sure that happens. So bananas, wait 2 seconds please, because that's how long the scratch cat takes to get over there. There is a wait block. Where is it? There it is. It's in control. Wait 2 seconds. Wait 2 seconds please, bananas. And I will add a comment just to remind ourselves why we're doing that. Right? It takes 2 seconds for the scratch cat to get to the bananas. So they're not ready to move yet. Okay? Does that make sense? That's my little sticky note, and that's a useful comment, right? So now if I run this program, boop. Bananas are waiting. This is the bananas program, and then they're gliding with the scratch cat. Beautiful. Any questions about that? Am I still missing something? I think I am. Is there a problem with the bananas program? You know the answer. And somebody else. Yeah. So these bananas, right, they're not going to start over there if they're already over here, right? So the bananas, they're gliding to that spot after 2 seconds, but I mean, they're already there. So again, they need to be started out in the fridge. Start them out in the fridge, please, at the very beginning of time. So that's go to. It's like a work block. So that's the bananas program, okay? So they are going to, they're going to wait 2 seconds to start moving, because then the scratch cat's touching them, and then they're going to warp to the same place that the scratch cat's going and take just as long to get there so they look like they're attached to him, okay? And that's the secret. And so now when I run it, they're waiting 2 seconds, and they're starting there if they weren't already there, and they're gliding on down to there. All right, now if I click the green flag again, they're going to reset themselves to inside the fridge. That's that coordinate. They're going to wait 2 seconds. Bananas are waiting, waiting, waiting. 2 seconds have elapsed. Now they're gliding, taking 2 seconds to do it, over to the edge. All right, so that's the bananas program. And here's the scratch cats program again, remember. So the scratch cat's going to start out right there, like warp yourself to the bottom right if you're not already there, and then take 2 seconds to get to the fridge, right? Glide, taking 2 seconds to get there, glide right back. So all those blocks are running in order. Both of these programs are running at once. And any questions about that? Does that make sense? Did we get it? Please yell at me. I want to know. So, if we are happy, again, just yell at me. I'm happy to explain more, go over things. I think that's the program, right? That's what I wanted to say. We have a good comment in there. It makes sense, right? And you can stop this midway if you want to with that stop sign, and it will all still work because of these initial places, right? We're warping them at the start no matter what. Even if like we stop it halfway through, like they're not done yet, we can make it work, right? They're all going to start out at the right starting positions, all right? So that's 2 programs running at once. Each program affects that particular sprite that it belongs to, okay? Bananas program, scratch cat program. I think that's all I want to say there, so I'll save that one so you can have it later. Are you ready for an even more complicated example? We're building our knowledge slowly but surely. So let's see. Here's my next example. Let's have an alien abduction example. So sorry, Scratch Cat. The Scratch Cat is going to get abducted by aliens now. And so I'm just going to write a program to that effect. So here's what I'm going to do. I'm going to make sure that the Scratch Cat appears underneath a UFO. It's going to send out its tractor beam and then warp up the Scratch Cat. It's going to glide into the UFO. All right, so this is like the process. I do want to teach you a new word first. It's called initialization. I think I accidentally said it already. For this program, what it means to reset these places, like the location of the Scratch Cat, the location of the bananas, to the starting point, that's called initialization. We've given them an initial value always. Does that make sense? That's the word, right? So you've initialized something when you've given it a starting value, starting place. So we initialize the Scratch Cat. We initialize the bananas, all right? So with that, let's have an alien abduction program. All right, so Scratch Cat needs to be like at the bottom of the window probably, and the best place to get abducted is probably like a cornfield or something, right? So let's find like a farm field. There's a hay field, even better. So that's where the Scratch Cat's going to get abducted. And he'll be at the bottom here. And so the game plan is there's going to be a UFO, and here, let me add that sprite. Let's add a UFO sprite. So here, choose a sprite. I don't think we have an alien sprite or a UFO sprite. So like you can get away with drawing your own if you want to, or I can just use I think there's a rocket ship. Let's just pretend this rocket ship is a UFO. Okay, so it's going to beam away the Scratch Cat. And so what I want to do with this program is the following. I want the UFO to warp into our atmosphere. So it starts out hidden, yeah, and then it disengages its warp drive. And then it appears. It's there now, right? So that's the first step. Then I want the UFO to lower itself, get a little bit closer to the ground, get ready to send out its beam. Then it sends it out, and the cat glides into the beam. We'll draw the beam in a second. And then the cat disappears. Scratch Cat disappears as if he has been warped inside. And then I would like the UFO to fly off. Whee! Just like that. That's the program I'd like to write. Okay, so let's give the Scratch Cat his normal name, Scratch Cat, and let's see what we need to do. So I would like a program for each of these guys, right? A program for each of them, and then also here I've hidden the Scratch Cat. Also, I need a beam that this thing is going to send out. So let's get that eventually as well. So let's see here. Why is there a little dot right there? I'm confused. Oh well. Yeah, I think we're good. So here's what I want. I would like the rocket ship to have a program. And I like the Scratch Cat to have a program. So when the green flag gets clicked, some things are going to happen for each of them. Yeah. And then I guess the first step is that the rocket ship starts out hidden. So I'll just click that. So the rocket ship is hidden. The very first thing I want the rocket ship to do is not be hidden anymore. All right. That is, I assume, in looks somewhere. Okay. There's a show block and a hide block. And that's exactly what we need. So show shows the thing, hide hides the thing. And it's always in reference to the current sprite whose program you're working on right now. So it's like show the rocket ship, because this is the rocket ship's program. Show hide, show hide. It's not too bad, right? So he's hidden right now, the rocket ship. And so at the beginning of time, we show the rocket ship, and then it needs to glide down. All right, so show, that's the rocket ship's program right now. And then we also want it to glide down, let's say, to maybe there. That's a good spot. Okay, so I can make a glide block showing that, right? Show yourself, rocket ship, and then glide down to there. So start out up here and start out hidden, and then show yourself, glide down to there. And if I click this green flag, you know the problem again, right? This rocket ship is not initialized. So we better make sure that it's in the right spot and hidden, right? So all right, what needs to happen with the rocket ship? How should it be initialized? It needs to start out up here, right? And hidden. So you can do that in any order. Let's say, let's start out hidden, and then we will also make sure it's at that exact coordinate, which we can just use this go-to block with that spot right there. Technically, you don't need this hide because it's like all these things are instantaneous, but like it makes sense to me. So if I click this now, if it was hidden, let's hide it, it would show itself, and it would work out. All right. So yeah, do we all see how these three blocks will execute instantaneously, and so like hide, warp, show is essentially the same as never hiding yourself to begin with. So those are the same. But if the rocket ship was eventually not visible, it would make itself visible and then glide down. Okay, so that's the rocket ship's program so far. Any questions about that? We good? Because what needs to happen next is the UFO should send out its little tractor beam so that the Scratch Cat can be successfully abducted. So let's do that. So there is no tractor beam sprite, but you can make your own sprite. So instead of choose a sprite and drag up here, it's paint. Paint a new sprite. So I click that. It's made a new little editor window for me, and I don't know, draw a little one of these shapes with the arrows, with the lines. This will be a tractor beam, right? Good enough. Boop, just like that. It's not perfectly straight, but you get the idea. And then I'll like fill it in with purple tractor beam. Perfect, right? And then I'll position it in the right spot. Oh, shoot. I don't know what I just did. Anyway, I might have to redo it. I think there might have been a bug in Scratch. But once you're done, like this is the costumes panel, you can go back to the code panel. And so now you have this new sprite thing. And for some weird reason, it's forgotten that mine has a shape. So I have a feeling just like there was a bug. I got to remake mine. So here, delete. I'll just do it again real quick. Who knows what happened? It makes a brand new sprite with whatever you wanted it to be. So you could have made your own UFO sprite. This is very cool. You get to be creative. So there it is. I'll go back to the code tab before it stops working. And again, it's still not visible for me. Wow, okay. I have a feeling I just need to reload my page. Sorry about that, guys. I want to save what I've done so far. So here, let me save that. Put it not in my downloads folder because that's not important. I'll put it on the desktop. There. Sorry, guys. My Scratch is unhappy. Oh? Let me restart my web browser. That is a very interesting error. So yeah, it was the web browser's fault, I guess. So this is how you load a file. Say load, and then you go to your desktop or whatever you stored it. Bam, bam. Like it never happened. Cool. So let me zoom back in. That's insane. All right, never seen that error before. All right, so back to where we were. Here's my tractor beam. You can get it where you want it to go. Let's get the rocket ship in place. Bam. So that's where the rocket ship's going to be. You can use your new tractor beam sprite and call it beam or something. Give it whatever name you want it to be. And then, like, it's in position, it can, like, beam up the Scratch Cat. The order is, like, not very set in stone. Like, when you click something, it will go in front of something else. That's fine. But I would like this beam to be transparent, right? Because it should be, like, part of the atmosphere, in a sense. So this is a filled in color right now. There's a way to make this beam become a little invisible. So that's in potentially looks, I think. So there is there's an effect, all right? There's a bunch of different effects. These are color effects. You can change color effects. Look at that, that's pretty cool. That's gonna change the color of the thing. There's other effects that you could have. Feel free to play around with them, but this ghost effect is what I'm getting at. So if we set the ghost effect of this beam sprite to like 50% as a percentage, it will be 50% invisible when I click it. Isn't that nice? So that's a beam. That's perfect. That's exactly what I want. And maybe it should be in front of the Scratch Cat. So there. Perfect. That's looking good. And so that's what I want to have at the beginning of the program for the beam, right? It should be a little bit invisible. And so they all are. We're working kind of together. We're getting there, right? So where was I? We've got the beam. It's been sent out. Or has it? Right? So like the rocket ship is not in place and then the beam's still showing itself. So I have a feeling what we could do is we could have the beam start out hidden, right? Have the beam start out hidden. At the very beginning, hide yourself, become transparent. And then only once the rocket ship is in place, send out the beam, have it show itself, right? So there's going to be like a delay in between here and here, yeah? That's what needs to happen, I think. That would make it pretty. So the question is, here's the rocket ship's program. How long does it take for the rocket ship to get into position? Can somebody tell me? I haven't heard from you today. Looking at this code, how long until the rocket ship is in the right spot for the beam to get sent out? 1 second. Good. Y'all see that? Because all these other two blocks, they don't have any seconds attached to them, so they're instantaneous. This one takes 1 second to do its job. That's how long it takes to glide down. So all three of the blocks in total, then, they take 3 seconds. All right? 3 seconds, or sorry, 3 blocks, 1 second, excuse me. 3 blocks, 1 second to do its thing. So that's how long we want to wait in between hiding and showing ourselves. So that's in control, and it was 1 second. Add a comment, right? It takes 1 second to for the rocket ship to glide down into position. Okay. So now this is the beams program. Look at that. Starts out hidden, waits a second. That means the rocket ship's in place. It sends itself out. It shows itself. Isn't that nice? Questions about that? So yeah, just please remember to shout out at me if you're at all confused. The issue as a professor is I can't tell if you guys understand perfectly because you're shy or because you're not talking or if you're shy. All right? So I need to know so that I can help. But yeah, that's the beams program for now at least. And then, all right, once all that's happened, now it's the Scratch Cat's turn, right? The Scratch Cat's turn to glide upwards. So again, we want the Scratch Cat. He's not done anything yet. We want him to glide upwards only once the beam is down. And now the question is, how long does it take for the rocket ship to get into position and how long for the beam to get down? Is that a trick question maybe? I think it is, because it's the same amount of time, right? After 1 second, the rocket ship is in place and the beam has been sent out. So that's how long until the Scratch Cat is ready to be beamed up. Yeah, it's 1 second, right? So that's how long it takes for the beam to get sent out. It's 1 second. There it is. 1 second. Show itself. Cool. So Scratch Cat, wait a second. This is how long it takes for the rocket ship / beam to get into position. And then we should be good. And then we're ready to beam up the Scratch Cat into the machine, into the UFO, and so glide upwards to, let's say, right to here. Okay. Take a second to do it, why not? It can be slow, fast, you can change these speeds. But let's say it takes 1 second to get there. That's what I've been using so far. So that makes this invisible. Let me drag that out. So glide a second into there, please, Mr. Scratch Cat. After a second. And again, we have an issue with initialization, don't we? So the Scratch Cat needs to start his life down here. So let's have him warp there at the beginning of time. So there's that. That's the Scratch Cat's program. Start out down there, always. Wait a second, be beamed up. Yeah? Start out there, wait a second, be beamed up. And now he's been beamed up. It's taken a second to glide there, so that's a program it's been running. The cat should disappear into the ship. Yeah, so he should hide himself. This is the cat's program. Should have him hide himself now. Bam. Wait a second, glide up, hide yourself. Yeah? And then we want to do the same thing for the beam, right? Same thing for the beam. Oh, we have another problem. Another initialization issue. I've said hide, but I've never said show for the cat, right? So if the cat's hidden, like he's moving technically, you can, if you watch closely, those coordinates are changing secretly, but he's not visible. So also initialize the Scratch Cat to be shown. Yeah, that's very important as well. So at the beginning of time, the Scratch Cat warps to down here, shows himself, waits a second, because that's how long the rocket ship takes, glides up, takes a second to do it, then hides himself. All right, this is getting a little complicated, but I think we're following it. Yes, questions? All right, so also the beam should go away because the rocket ship's like it's done its job. So the beam and the cat should disappear. So the question is now, how long until the beam disappears? So the beam's out, took a second to get out. How long does it take for the Scratch Cat, when the beam is out, to get abducted? Yeah, thank you. The answer, I've made it easy for you. It's always 1 second apparently. But that's this, right? That's this part. It's going to take a second for the Scratch Cat to glide up. So the beam needs to be visible for 1 second, right? That's how long it takes for the Scratch Cat to glide up. And then it can be hidden. Okay? So wait a second. Hide yourself. So there's that comment. Can I put this over here? Not in a pretty way. So it takes a second for the cat, Scratch Cat, to be beamed up. So that's how long. If you look at this closely, you'll see that's how long the sprite is visible, right, in between the show and the hide for 1 second. That's what that must mean, right? Boop. It's visible for 1 second, hides itself. That's the beam's job. Cool, we're getting there, right? We're getting there. And then I think the last thing I want to do is have the rocket ship fly off. And then, I guess, hide itself. So let's do that. But we're almost there. Are there any questions about any of these programs so far? So the Scratch Cat is doing all these things. Staying there, getting beamed up, hiding himself. The rocket ship. Making sure it gets shown if it was hidden. Getting into position for now. And then the beam is waiting for the rocket ship, waiting for the cat, and then hiding itself. I'll explain that in more detail in a second. But all right, the rocket ship's done its job. It's ready to fly off into outer space. So let's have him like glide off up there and then hide itself. All right, so it'll glide. So wherever that is, after everything's happened, right? And then it'll hide itself. So now, I guess the last piece of the puzzle is to figure out, well, how long do we wait in between here? How long does it take for the Scratch Cat to to get beamed up and for everything to work out. And I think the answer is always a second, right? So it's the scratch cat took 1 second after the rocket ship was into position to glide up and hide itself. So that's how long the rocket ship should wait before gliding off. This is wait. You'll watch it when it runs. It'll stay still, right? Stay still for 1 second so that the cat can be abducted. That's the job of the rocket ship now. There it is. Waits 1 second. There it was still. Flies off, and then it kicks in the warp drive. Yay! I think that's the program. Let me explain each part in detail now. So let's see. The scratch cat. What is the scratch cat doing? He is, at the beginning of time, he's warping himself to down here in the middle. And then he's making sure he is shown. If he was hidden, and he is right now, then he will wait 1 second, because that's how long the rocket ship takes to get into place. It's going to wait a second. It's going to stay still for a second, right? Pause. And then he will take 1 second to glide up into the rocket ship. And then the final thing after that's finished is to hide himself. That's the scratch cat's job for this program. Okay. Then the rocket ship, what's it doing? It's going to make sure that it starts out up here, right? Up here, it's going to warp there and then show itself if it was hidden, and it is. So there it is. And then it's going to take 1 second to glide down into position. There it is. 1 second, glide down into position. And then it will wait 1 second. It'll pause for a second. That is paused, because that's how long it takes for the cat to get beamed up. And then it will glide off again. Wait a second, glide off one more time. That's this one. And then after it's done that, it hides itself. It gets kicked in the warp drive. That's the rocket ship's program, and that's its job. And then finally the beam. So the beam doesn't ever have to move. It just has to show and hide itself, essentially. So, and also become transparent, because it's prettier that way. So the beam makes sure that at the beginning of time that it's hidden and that it's transparent. And then it just stays still. It waits a second, because that's how long it takes for the ship to get into place and to send out the beam. It takes 1 second after the green flag gets clicked. It's waiting, paused. Then it shows itself. And then it stays shown for 1 second, right? That's how you can read this, right? In between show and hide, there's a wait 1 second block, which means that's going to stay shown. It's going to pause after it's shown for 1 second. Then it'll hide again. And that's exactly how long it takes for the cat to get beamed up, all right? And that's the trick. And it hides itself. So all three of these sprites have their own program, and they're all working together to complete the animation. I think that's a cool little example. Are there any questions about any of that I just did? I think that's a fun program, and I will give this to you, of course, eventually. But what I want to do now, then, is, first of all, make sure that you've done attendance if you haven't. I would like to stop that. I'll stop that after this question I'm about to give to you. I want you to play around now. All right? That's the best way to learn these things. Go scroll through the blocks, try them. First of all, recreate what I just did if you haven't already. If you were lazy, do it now. I'm going to give you all this code. Here's the Scratch Cat's code, and I'll keep him visible so you know that was his code. There it is. Scratch Cat's code. The rocket ship's code. Boop. And I'll also come around to help you if you have any questions about anything. But I want to give you some time just to play around. It's the best way to learn. And here's the beams code. Boop. So there's all that. And what I'd like you to do is take my example, recreate it first, and then change it, please. We have plenty of time to do this. I'd like you to change it, maybe have the Scratch Cat get away safely, have him yell obscenities at the UFO or something and run away. Like, you know all those blocks now. You can have him say stuff. Have him say mean stuff if you want. That's fine. So there's my code. Change it. Change it to do something else. Maybe have the Scratch Cat get away. You can make a new sprite that has flames. Like, you can have the Scratch Cat throw the bananas at the UFO and have it show the flame sprite to see that the UFO is burst into flames or something. Like, there's so many options now. The world is your oyster. You're a programmer. I think that's cool. So I'm going to give you several minutes to give this a try. Play around, please, and I will be here to help you. And also share your cool stuff with your neighbors sitting near you. Help each other. And I'm here to answer questions as well. Now, some of the hardest problems are figuring out how long to wait, and then also initialization. You will notice. We're tackling them on the first day. Couple more minutes. Send this out. They'll have plenty more time to play, though. Alright, that's the little timer that I set, at least for us. Are there any questions that came up as we were playing along? You'll have plenty more time to play along. I will give that to you in just a second. Would anybody like to share what they did? Was it super cool? You want to show it to the class? Let me know if you would like to. We can find a way. Like get on Zoom, you can share your screen or something up here. But yeah, if we're all too shy for that, I would like to just give you your first programming assignment now. Okay, so here's what I want you to do. It's going to be, for those of you who have never programmed before, you're going to do a Scratch project. Scratch-like project, I guess. And I'm not sure if I saved this, so I'm going to save again, just in case. Okay, good, I did save it. Let's see. It's going to be on Canvas, of course, and it's going to be this one, Programming Assignment 0, because numbers start at 0 in computer science? We will soon find out. So here it is. It'll be due in a couple weeks because there is a holiday next week, right? It's on Monday, right? As far as I remember. These things, I don't really remember them very easily, but I think we have a holiday on Monday, so there's only one lecture next next Wednesday only. And so for that reason, usually during normal semester, this is due in a week, but this will be due in 2 weeks because of that. All right, so here's your job. Like I said on Monday, if you are a programmer, you have a different assignment. All right, if you've already programmed before, the assignment that I'm giving to the non-programmers, the people who are just learning to program right now, is too easy. All right, even though if that is you, it's going to be perfectly at your level. All right, so let's see here. So yeah, there's going to be two options. One if you're new to programming, and one if you programmed before. You're going to pick the one that applies to you. So if you have never programmed before, this is your first programming class, you're new to it all, Scratch is cool, I'm going to have you do something Scratch-like on this website called hourofcode.com. All right, so you're just going to go there, and there's just a bunch of cool little things that you could do here. It's like you're going to spend an hour coding. You can click whichever one you want. All right, you can do the music one. There's one with like Minecraft, a few with Minecraft. You can make a Flappy Bird game, whatever you would like, whatever interests you the most, you click on and you'll do. All right, so there's just a bunch of different activities that have to do with coding somehow. It's going to give you a Scratch-like environment to build a program, and it will walk you through how to do it. So you can click whichever one you would like and do it. Find the one that interests you, and that's pretty much it. At the very end, once you've completed whatever that was, it will tell you that like you made it to the end, and like it'll either give you a certificate. Some of them will like give you a little certificate that you could print out, or some of them will just say like, all right, yeah, you've checked all the boxes, they're all green, you've completed, you're on the last level or whatever. So what I want you to do to turn in your work and show me that you finished everything, just give me a screenshot. You'll upload a screenshot into Canvas that either shows your certificate that you got, or just like shows all the green check marks that you're on the last level and you completed the thing. Okay, does that make sense? So that's what you're going to do. Not too hard. And so that's the hour of code activity. I think you'll like it. All right. And then also, can I stop attendance? Has everybody done that? I forgot to do that before. There. All right, we're all here now. So that's the activity for you if you are new to programming. If you have programmed before, I've got some options for you. All right. If you would like, I can give you, like, we can come up together with a custom programming assignment for you. I want you to learn something brand new, and I'm happy to work with you on your interests, and we'll figure out something for you that's the equivalent of like an hour of work for this first example. But yeah, let me know if you would like something custom. We can talk about things like either after class or in my office hours. We can get you something so that like it's at your level. If you just want to do something that I've already pre-planned, here's your other option. All right. So what I would like you to do, if you would not like a custom thing and you've programmed before, I would like you to learn a brand new language called Racket. All right. It's a weird one. It's going to melt your brain. And then here's a textbook that people use to teach Racket. You'll click on it. And what I want you to do, it's part 1, right? I want you to go through chapters 1.1, so sections 1 and 2 of chapter 1, essentially. These two guys. And so it will teach you this brand new language called Racket that has nothing but parentheses all over the place. It looks really weird, and it's super cool what you can do with it. You have to install the Racket language on your computer. It's called Dr. Racket. You can just search for Racket install. It should probably give you a download link. And it's called Dr. Racket that you would load in and run that on. Question?
We just did like an online editor.
No, I want you to install it because like the program itself is super special. You can program with images and things. The online editors won't let you do that. Yeah, that's going to be part of the exercise eventually. Let's see. So yeah, you got to install that, and then I want you to do, after you've read those chapters, I'd like you to do just exercise 2 because it'll take some time to read the stuff. So do exercise 2, which I assume is in 1.2 or something. There it is. This one. Do that exercise. Show me a screenshot of it working out, and that's your program. All right, and that's what I want you to do if you do not want a custom assignment. Are there any questions for those of you who have programmed before, what your job is going to be. All right, so yeah, I want this on the 30th apparently, which is not next week because of the holiday, but like 2 weeks and a day from now, apparently. Okay, so week 3 is when it will be due. And I think that is everything that I wanted to say. Any questions about either one of those programming assignments? We good? All right, so yeah, as usual, we've got some extra time. You are welcome to stay and just like keep playing on Scratch until the time is up and ask me lots of questions.